Students, good morning. Am I audible? Can you able to hear me?
Yes, ma'am.
So those who are entering, kindly mute yourself.
Yes, ma'am. Audible, ma'am. Good morning, ma'am.
Yes, good morning.
Screen is not visible, ma'am.
Yeah, it's not yet shared. Thank you for the information. The screen is not yet shared. I have not shared the screen yet. Is it visible? Is the PPT
Yes,
visible
ma'am.
now, right now? Okay. How did you all do your assessment?
Yes, ma'am. Good, ma'am.
Very good. So we have also evaluated the copies. It will be sent to you. It will be released very shortly. Soon after
Ma'am,
me.
today
Yeah.
release, ma'am.
Today? Today? Come again? Isma? Somebody asked me something. So shall we start the class? How many are there in the class? 48 of you are here. Okay, without wasting any more time. Just I will refresh with what we have done so far in this unit. So we are right now in unit 2 only. We were dealing with the data link layer. So this is the syllabus which So we have the error detection and correction, line discipline, flow control and error control, and the medium access control, in which you will be dealing with the wired and the wireless different protocols. Okay. So the very first half of it is completed. Data link layer is the layer between the physical layer and the network layer. It gets the service from the physical layer and it provides service to the layer above it, that is the network layer. And it is the data link layer which is going to take the raw data, that is the bits, and it is going to be made in form of packets. Sorry. Yes, ma, students, mute yourself. Shrikant.
Yes. Sorry, ma'am.
Okay. So it is the data link layer which is responsible for the framing. It means it is this layer which is going to resolve so many issues, that is relating to the flow control, line discipline, as well as error control mechanism. It means flow control implies how the flow has to be, how to identify whether the frame that is transferred from the sending end is effectively received at the receiving end. That is by the provision of acknowledgement. And if there are so many stations or the sources want to use the medium, how to resolve the issue, and then how to resolve the issue when there are more, when the error comes into a picture. So the
Ma'am, one
medium.
doubt, ma'am.
Yeah, ma'am.
Now, computer architecture and organization class, ma'am, but
Yeah,
next
ma'am.
class is.
Yeah, ma'am. Yeah. Actually, we have this. There is a revision in your timetable. Okay, it's not it. Issued to you. It's not yet shared. It's not yet shared to you.
No, ma'am, share that previous timetable, ma'am.
Okay. It will be shared to you shortly. Actually, we have 3 days in online and 3 days in offline, right? Isn't it? So you are going to have classes for
Yes,
3
ma'am.
days in
3 days
online.
offline, 3 days online.
So because of that, there is a small slight rescheduling in the syllabus. In the what to call your timetable. As per that, every day from this week onwards, you will have first hour for data communication. Every Tuesday, first hour will be data communication hour. So we are allocated with 2 offline class and 2 online class. So today
Okay,
we have one online, and tomorrow second hour we'll have one more online. And I think Thursday when you come to college, you will come to know. I think Friday.
ma'am was shared, ma'am, that PDF.
Ma'am would have shared, right?
Yes, ma'am. Yes, ma'am.
Okay. So this is all about your data link layer. So this part we have completed. Now moving on to the medium access control, let me tell you what it is now. So today we will deal with that. What is actually a medium access? You know, it's a medium means it is the region through which the data is going to be transferred. It could be a wired medium, it could be a fiber optic cable, it could be twisted pair of wires, any wired medium, or it could also be the wireless medium where air will be the medium for transmission. So if too many sources wants to access the channel, how to resolve the issue? That is taken care by the different methods, which is called generally as the medium access control method. So what is the procedure that this system is going to follow whenever it has to send the frame, and when too many users wants to send or take the control of the medium. So that is said to be called as the medium access control methods. And actually we know in the data link layer, the data link layer is the layer in between physical and the network layer. And IEEE, when they were when they were trying to resolve this issue of medium access control, they decided to divide this data link layer into two halves. That is the logic link layer, which will take care of the all the things which I told you earlier, that is flow control, error control mechanism. And the bottom layer, that is which is connected soon after the physical layer, is said to be called as the media access MAC layer. Okay, so it is this MAC layer which we are going to deal now. So it is the lower layer just above the physical layer, and it is the lower sublayer of the data link layer. Okay, and it is actually designed by IEEE in order to standardize various, that is when too many sources wants to have the control of the channel, or when they want to transfer data to the channel. They decided that there should be some kind of a rule or procedure that should be followed in order to effectively transfer the data, even when more than one source wants to transfer data. Okay, and earlier it was actually meant for the wired medium, which is the IEEE 802.3 standards. Later on, which you generally called it as the Ethernet. Okay, whereas later on it was meant for the wireless medium, where IEEE has given one other standard which you will be studying later. Okay, and this medium access control, let us we call it as the protocols. You know what is meant by a protocol? What is a protocol? Set of rules that is going to define when multiple access, it means when many number of sources wants to access the channel, how the problem is resolved. That is what is the rule that is being followed for this multiple access problem. Okay, so that is broadly classified into different protocols, and all of them are put under three different categories. As you see in the slide, we have the random access protocol, next is the controlled access protocol, and the third one is the protocols which are that is FDMA, TDMA, and CDMA, which are the channelization protocols. So as per the syllabus, we have only this random access protocol, in which you will be dealing with all these protocols. So this ALOHA, CSMA, CSMA CD will be meant for the wired medium, that is Ethernet IEEE 802.3 standard, whereas CSMA CA is meant for the wireless medium. Okay. Any doubt? Shall I proceed further? It's just an introduction. Shall I proceed? So what is actually meant by random access? So random access method is also called as the contention method. It means here the stations, that is the source, is said to be they can able to have control of the channel in a random manner. It means there is no something like there's no any kind of superiority among the channels, or sorry, among the stations or among the sources. So there is nothing like the channel is assigned to one particular source. Okay, so it means no station permits, or it will not also prohibit the sending of the frames by another channel. Okay, so if a station finds, if any source they wants to send data through the channel, then of course they can send the data through the channel. Okay, so and again there is no time limit also for the source to transmit. If any station finds, if any source wants to transfer some data, it can very well transfer the data through the channel. No other station will have control on this source for transfer of data. Not only that, it will also, there will not be any time limit for one station to stop the transmission. Okay, so since the transmission is said to be random, we call it as the random access method. Okay, so as I told you, there is no rule to specify which station has to send the data soon after one station completes. Okay, so it's like the survival, whoever is best in the competition will be winning the show. So stations, they will compete with another, and in they whichever is winning, they will be accessing the medium. It's also called, that is why it's called these two features. As you see here, it is, there is no scheduled time for the station to transmit. It means, as I told you, if any source they want to transfer data to the channel, as such they can transfer the channel. So the the methodology, or the time to access the channel is not constant. It is said to be random, so we call it as the random access method. Second, there is no rule to specify when one station completes the data transmission, the other station has to follow like that. So that is why this method is also called as contention method. Okay. So as I told you, there is no kind of hierarchy. Every station has the full right of the medium, and it does not control any other station from sending the packet. So as a result, if one station, that is if one source, they have some data and if they want to transmit, they will be transmitting. Likewise, at the same time, if the second station also wants to transmit, they can also transmit the data. So what will happen? The end result is lot of collision will take place. So as a result, this random access method will result in collision, and you see the frames that are transmitted will either be destroyed or they get corrupted. So this is the problem which is available with the random access protocols. And the very first protocol is the ALOHA. ALOHA stands for Additive Links Online Hawaii Area Protocol. Actually, it was meant for the ground-based radio broadcasting. And the main idea with this protocol is, see, I can explain with this diagram. Just a second. See here, what happens is station one. So this dotted line is the medium. Okay. So station one is transmitting a frame. This yellow color is the frame that is transmitted from station one. Likewise, station two is also transmitting the packet, and four stations are shown here. They all transfer packets. So what is happening here? Station one is transmitting the frame, and as you see here, there is no collision in this duration, whereas station the packet from station 1, where frame number 1.2 from station 1 is said to be colliding with the station 2 frame 2.1, as well as with the other two frames from station 3 and 4. So, and again, here also we find there is collision taking place. Only out of how many? 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 frames that are transmitted, we find here there is only 2 frames that does not have any collision. So that is the main problem with this ALOHA. So I can say that in case of pure ALOHA, the frames are transmitted at a completely arbitrary time. There is nothing like duration between one frame to the other, or the duration, some time delay between one station with the other. Okay, so it is said to be, the frames are said to be transmitted at a purely arbitrary manner and arbitrary number of times. Okay, so what is happening here is the sender, that is the sending end, the source will find, uh, will, after sending the frame, will check whether it gets an acknowledgement. If it does not get an acknowledgement, it will identify that its frame is lost, and it will again resend the frame. Okay, so and that is the problem with the pure ALOHA. See here, so this is the algorithm for the pure ALOHA protocol. As you see here in this flow chart, there is K being assigned, which is corresponds to the number of atoms. So in most of the random access protocols, the maximum value, that is this protocol will try to send the frame at a maximum of 15 times. It will try sending the frames for maximum 15 number of times. At the end, after the 50th time, if it finds there is no possibility of sending the frame, it will just abort the frame. It will no more transfer the frame. So most of the this random access protocols, they will be making maximum 15 atoms for transferring a frame. So as such, when you one station, they will be sending the frame, and then it will wait for, so if I say TP as the maximum propagation time. See, I have station here, and this is the sending end, and this is the receiving end. So a frame that is coming from here, okay, it has to transfer, it has to go here, and on reception, the receiving end will send an acknowledgement back. So if I say T suffix P as the time taken to, that is propagation time, time taken by this frame to reach from the sending end to the receiving end, if I say it is as T, propagation time TP, then to receive the acknowledgement back, one more delay, that is propagation time delay is required. So altogether, the wait time will be 2 times of the propagation time. Okay, so this station, after sending a frame, it will wait for this duration, that is wait timeout time. So this waiting time, till this time it will wait, then it will check whether it has received the acknowledgement. If the acknowledgement is received, it is an indication that the frame that is transmitted is successfully received at the receiving end. So this is success, so it will go for the next. Otherwise, what it will do? It will increment the number of atoms by 1. So, and again, it will check whether the number of atoms has reached 15. If not, it will wait. It will select a random number R, which can be from 0 to 2 power k minus 1. So 2 power 15 minus 1. So among this, that is 0 to 2 power k minus 1, between this, some number, random number R will be taken, and that duration it will wait before it transfers before it resends the same frame. Understand? So this is the protocol that is pure ALOHA. So what is the problem with this pure ALOHA? So here the problem with the pure ALOHA is there is no provision here to avoid any collision. And again, you find that there is a lot of chances for the frames to get collided, and as well as for corruption of the frames. So to avoid this, an improved version of protocols were actually designed. And the very first one among this is the CSMA, that is Carrier Sense Multiple Access. So what is this Carrier Sense Multiple Access? that is here, the stations, they will not just like that transfer the frame, but what they will be doing is, and they will be just listening to the channel before they transmit, as well as they will sense the channel. They will sense the channel before they transmit, and will also listen to the channel before they actually talk. So you say that CSMA is based on the principle of sensing before transmitting or listening before talking. So just like that, you will not, this station, that is as per this protocol, the stations will not be transmitting the frames randomly, but even though it comes under random, there will be some kind of sensing process taking place before the actual frame is transmitted. So those protocols where the stations are going to listen to the transmission medium before they actually transfer the frame is said to be called as carrier sense protocols. And the improved version of CSMA is only CSMA CD, and followed by that we have CSMA CA. CSMA is the very first protocol designed under random access protocol, where it is an improvement of the ALOHA, and it is going to listen to the channel before it actually transfers the frame. So actually this protocol is the improved version, as I told you, so that the chances for collision is said to be minimized. Okay. So we see here that we'll see the types. First one is one persistent CSMA, second one non-persistent CSMA, and P persistent CSMA protocols. So we'll see to the one persistent CSMA. Actually, this one persistent CSMA is said to be the very simplest among the three, and it is just very simple. What is happening here is, if the station finds that this medium is said to be idle, it is going to immediately send the frame. So we say that it is one persistent implies the probability of sending the frame is one immediately. So what is actually probability of getting, say if I throw a coin, okay, what is the probability of getting a tail? What do you say? You know, right? Probability. Yes, students, can you able to get what I'm saying? Can you able to hear? Yes, ma. Somebody respond. Somebody respond me.
Yes, ma'am. Able to hear you,
Yeah,
ma'am.
thank you, ma. So what is meant by probability equal to 1? It means there is every chance. There's no nothing like there is no chance of a failure. Means probability means sure. Of 1 means surely it will happen. Okay. So here what is happening? It's said to have a probability of 1. It means if a station finds a line is idle, the medium is free, it will immediately send the packet. So if this method is said to be followed, then what the problem with this one persistent CSMA is, again there is a lot of chance for collision. It is because only, I'll just show you. We'll just move on to the next slide. So here you see station A. What is happening? Station A is sending a packet at time T1. So frame at time T1. So the frame that is transferred is traveling through the medium, and at the same time, station Z at time T2, when it listens to the channel during time T2, it will find that the channel is free. It's because that during time T1, that is when the frame is released from the station A at T1, and it would have this A's frame would have reached here alone during this time T2. So because of that, from the point of station Z will assume that the channel is free. because the frame from A has not yet reached this place. So it will it will think that this channel is free, so it will release a frame from at time T2. So these two frames, when they are traveling to the same channel, at this point, that is at the, during time T3, they tend to collide. So on collision, even after collision, none of the stations are aware of this collision. So as such, after collision, that is this packet will travel from Z and it will reach here. That is and both of them will be traveling in their desired path, and they will be reaching T. That is the packet will be reaching Z station at T4. Likewise, station A will be receiving the packet at time T5. So from the time that is during time T3, collision has happened. So if there is some provision to tell both the stations that a collision has occurred and to immediately abort the transmission or abort the frame, then this duration could be saved. So that is the main idea behind, or the main problem with all the CSMA methods, with all the three different methods. So we'll see with the other two, we'll see here. So I told you we have the three different types of CSMA. First is one persistent CSMA. See here, in one persistent CSMA, the station, they are having, a station is having a packet, a frame to transfer. It is keeping on checking the channel. See till this time, that is this blue color indicates the channel is busy. So, and every time when it checks the channel, it is finding that the channel is busy, so it is not sending. But at this point, it finds the channel is free, so immediately it is sending, it is releasing the frame to the channel. Okay, so this is one persistent CSMA. We'll see with the non-persistent CSMA. So here, what is happening? Again, this station, before it transfers the frame, it is checking the channel. It is finding it is busy. So it is waiting for some random time, and then it is sensing the channel again. Again, it is checking the channel, not immediately, but after waiting for some random time. And then if it is checking, during the time when it checks it is free, it is sending the packet. That is non-persistent CSMA. Whereas in P-persistent CSMA, see here how clever the channel is now made. See, in P-persistent, we are saying that here the same process is happening. When the station finds the channel is busy, it is not sending. And then if it finds that the channel is free, it is not transmitting, it is waiting. It is waiting. It is the probability here. When it is going to transfer is, it's based on the probability P. The probability, some probability is chosen. Based on that probability only, it is going to transfer. Suppose there is 0, if the P value is said to be 0, then this channel is, this station is not sending the packet. It is waiting for certain duration. Again, it is selecting some random P, and only if the P value is making the channel, making the station to allow the frame, only then it is transferring. Like this, we have the P persistent. Because of this, there is chance, it is reducing the chance of collision. It is trying to avoid the effect of collision, because if two stations, see here, this is the flow diagram, with one persistent, just channel is checked. If it is busy, it's keeping on checking the channel. If not, again immediately it is, the station is transferring the packet. Here the channel is checked. If it is busy, some time delay is given, and after that the channel is checked. Immediately after the delay, if it finds during the time, if it finds the channel is idle, it is sending. But in P persistent, the channel is checked, If it is busy, it's checked again and again. Whereas if it is ideal, it is not, the packet is not, sorry, the frame is not immediately sent, but it is going to wait. For how much duration? It depends on the probability P. So if the probability P is said to be making the channel, allowing the channel to transfer, only then the channel, the station is transmitting the packet. Otherwise, it is just going to wait for certain time delay. And again, it is checking. Again, the process is getting repeated. This process somehow avoids the effect of, effect of collision, because when two stations, they want to transfer the frames, there is less possibility of two stations as given with the same probability. Say one is given a probability of 0.5, another one can have another value of probability. So at a time, if two stations, even when two station wants to transfer the frames, there is less possibility of the two stations given with the same probability. So by this method, the effect of collision or the collision itself is somewhat avoided. Okay, so this is all about the CSMA, but with the CSMA also has an issue, that is the possibility of collision here again still exists, still prevails, because the propagation delay. When a station sends a frame, it still takes time for the first bit to reach every station. As I told you, okay, so here, even though these provisions are given, there is no provision here to look in for the propagation delay. Only this CSMA looks in during, that is, it is going to resolve the problem with respect to the starting point of the frame. But in between, based on the delay time required to transfer, that is required for one frame to reach the destination, there is possibility of collision in between. So the CSMA does not include the propagation delay, so it may result in collision. So to avoid this, the next improved version of CSMA is made, that is CSMA CD. What is CSMA CD? So CSMA, you know, carrier sense, multiple access, and along with the CSMA, original CSMA, there is provision here given for collision detection. So you know the same problem occurs here also. During time T1, station A sends the frame, and during time T2, station D, it senses the channel as this frame from A is not received during the time T2 to the station D. Station D assumes that the channel is free. So it is, station C assumes that the channel is free. So it is sending the frames. So both sides it is sending. So here during time T1, the frames are sent from A. During time T2, okay, this frame. So here during time T2, just simply I'm drawing. During time T2, from the, for the station B alone, it will see that during time T2, it has reached station B. So when station B looks into the channel, it will come to know that the channel is not, it's busy. But from the point of station C, since the channel is, even though the channel is being used by station A, it will not come to know, because the frame is on the way. So this channel, from the point of station C, it will assume that the channel is idle. So it will release the frames on either side. So what is happening here? The same channel, through the same channel, both station A as well as station C are going to transmit the packet. So as a result, a collision occurs. So here collision is occurring, that is during time. See, collision, first bit of A, and it is getting collided. And at the time of, after the collision is happening, the provision that is made in CSMA CD is, okay, the time, during the time of collision, when the collision has occurred, that is indicated. There is a provision added to CSMA to indicate that a collision has occurred. So when the message that is C's collision is detected, and when that is sent to the station C, and when it is assumed that information that a collision has occurred is transferred, and during time T3, if it is receiving the station C, then station C will immediately abort the frame. Likewise, from the point of station A, T1 is the time during which the frame is transferred, and during time T4, it is informed that there is a collision has happened, so it is immediately as soon as it gets the information, it is abort, that is the frame is aborted. So the transmission time is effectively reduced. Previously, without knowing, it was just waiting till time T5. Now the transmission time is reduced here because of an extra provision here given to indicate these two stations about the collision that has happened. Okay, so that is the CSMA CD. So the same diagram is repeated here. Now moving on to the algorithm, that is the flow chart. Like how we had with the CSMA, same procedure is adopted here. So we start, and the number of attempts is initialized with 0. Then any of the persistent method, one persistent or non or p persistent methods are adopted. And then here it is not the station that is going to only do the transmission alone. It is also going to receive one other extra signal, that is the uh, information relating to the collision. So any of these signals, transmission done or collision detected, if they are going to be received, then it is going to see here. If any of this signal is said to be received, then it is said to check whether collision has happened. If there is no collision, just like that, it is going to come out. If yes, then there is a collision that has happened, so it's going to send a jamming signal to indicate the other stations that a collision has happened, and then the same process like with the CSMA is going to repeat here also. That is the CSMA CD. So what is the actual difference between this CSMA CD with ALOHA? That is the addition of persistence process. So as such, just like that, the frames are not sent, but here they are going to be based on the any one of the persistent method. So by using some time delay before actual transmission, there is less chance for the occurrence of collision. Second difference, that is what is happening here is with the pure ALOHA, we find that the frames are only transmitted, and then the channel will be just waiting for the acknowledgement. But here in CSMA CG, the process of transmission as well as the detection of collision is not said to be it's not a different one. It's said to be a continuous process. Okay, like I can say that the entire frame is not sent, and it's not going to look in for the acknowledgement. Whereas in CSMA CD, the station will transmit as well as receive the, that is transmit the frame, as it will also receive the information regarding any collision. So it's going to be something like a loop process. So that is enabled, that is by sending the jamming signals, so that any collision, if it has occurred, it is going to be indicated to all other stations regarding the information, that is the collision information. So that is all about CSMA CD. Okay. Now, why do we actually go for CSMA CA? Because these random access protocols which I was telling you right now is that is a pure ALOHA or CSMA or CSMA CD. is mainly meant for the wired medium, that is the Ethernet medium. Why actually we cannot use the CSMA CD method for the wireless medium? It's because I just tell you, as I told you earlier, here, if you look into the station, so this station is capable of transmitting as well as getting the receiving the information, collision information as well as. So when I say about station, this station is capable of receiving acknowledgement signal as well as collision, that is jamming signals. So how do the station identify or differentiate between the jamming signal and the acknowledgement signal? So there comes the that is the requirement of CSMA CA. So at the station at a time can able to receive both the jamming signals in case of any collision from any other station, as well as it can also get the acknowledgement signal. So how do the station differentiate between the jamming signal or the acknowledgement signal? It is because that is if I say in a wired medium, in an Ethernet medium, what will happen is when the acknowledgement, when the sending end is sending the signal, and when the signal is received, that is when the acknowledgement is received, it's of course going to take the same path. So the energy level, that is if I say E1 is the energy level of the transmitted frame, then the acknowledgement frame also will be getting an energy level equal to E2, which will be the same. E1 will be equal to E2. Whereas when a collision has occurred, the E2 value, that is the received signal level, will be more than that of the transmitted signal level. By using the by identifying the energy level present in the signal, the the source can able to easily differentiate whether what it has received is the acknowledgement signal or the jamming signal. So that is possible only with the wired medium. Whereas if you take a wireless medium, there is no much difference between E1. So if I say E1 is equal to E2, then it is implied that's an acknowledgement signal. If E2 is greater than E1, then it is said to be equal to the jamming signal. Whereas if I take for a wireless medium, what will happen is if I say my sending end as a sending signal as an energy E1, then the received signal both, that is for both for acknowledgement as well as for jamming, will not be differing much. They will be more or less having the same signal level. It's because when the so I mean, through the wireless medium, if these signals are transmitted, there is every chance for the loss of energy. So we cannot say always that there will be energy level matching in case of acknowledgement signal, and more in case of collision signal. There is every chance for the signal level getting reduced in both jamming as well as in the acknowledgement. So the station will not be able to differentiate the frame, that is the signal that is received, that is it could not differentiate between acknowledgement or the jamming signal. So that is why they say, or that is why CSMA CD protocol is not suitable for wired medium. So it is again there is some more improvement with CSMA, and that is called as CSMA CA. C, that is carrier sense multiple access with collision avoidance. Where do all these problems cause? Only when there is a collision. If there is some provision given in this protocol to even avoid the collision, then there is no possibility of detecting, there will not be any requirement for detection of collision. So that is why just modified, or they just improved the CSMA protocol with the provision of collision avoidance. So with the collision, to avoid the collision, three strategies are followed. One is the interframe space, second one is the contention window, and third one is the acknowledgement. So just I'll tell you what it is. What is this interframe space? So what is this actually interframe space? What is happening is, as per this CSMA CA, collision has to be avoided, isn't it? It means even when the stations, after the station finds that the channel is idle, it should not transmit the frame. It's because there is every chance for the some other station would have started the transmission and the frame may be in between. It may not have reached the station, but still it may be using the channel. So there is going to be some wait period between the actual transmission, and that wait period is said to be called as interframe space. Okay. So as I told you, even though the channel, when it is sensed by the station, it will look as if the channel is idle, but the channel may not be completely idle because some other station at some other end would have started the transmission. So because of the addition of interframe space, there is a possibility of no two channels being transmitting the frame. Because of the addition of interframe space, somehow the collision is going to get avoided. Okay. And again, here with this interframe space, some kind of prioritization is also said to be incorporated. It means the station which is said to be assigned a shorter interframe space implies the station may require to use the channel immediately. So that will be given more priority. So likewise, some kind of prioritization is also allocated. Second is the contention window. It means there is, that is, if I say the total time, some duration is taken and it is going to be divided into equal to, that is divided into number of slots. Okay. And each, that is again, after the station is going to wait for the interframe space, still the transmission is not going to start. It is going to wait for certain time slots. Only then it is going to transmit the frame, and that is said to be called as the contention window. And after all these, if there is said to be some collision going to happen, then there is a provision here, that is by use of positive acknowledgement as well as the timer unit, the receiver is said to be, that the sender end is said to be indicated with this collision. Okay. So that is all about your CSMA CA. Now moving on to this flow diagram. As you see here, the process is going to start with K. It is checking the channel. That is any of the persistent method is adopted. If the channel is said to be free. If it is not, again the process is going to get repeated. So if the channel is found to be free, immediately the process of transmission is not going to take place, but it is going to wait for interframe space. Again the channel is still. If still it is idle, then a number, random number between, that is contention window of size 2 power 10, certain R value between 0 to 2 power k minus 1 is said to be chosen. And again for this certain duration, this channel, the station is going to wait. And then it is going to send the frame, and then it is going to wait. After sending the frame, it is going to wait for certain duration to receive the acknowledgement. If the acknowledgement is received, then no problem. Then it's a success. If not, it is going to increment the number of attempts by 1, and it's going to check whether it has reached 15. If not, then it is going to repeat the process of resending the frame again and again up to 15 times. If it reaches 15, it is going to decide that it cannot transmit the frame to the channel, and it is going to abort the process of transmission. So any doubt you have up to here? I'll just, if possible, I will just add on this. So any doubt, Ma, you have up to now? So next class, ma'am will be taking the next hour, the tomorrow's hour. Okay. I will also tell you this, how many more minutes? Only 5 more minutes. How many more minutes, ma, for the next hour?
4 hours, Chief.
4 minutes. Okay, then. So as such, if you look into your syllabus, see here, as such, today we have completed this CSMA, CSMA CD and CSMA CA. Actually, they all come under the medium access control method. So medium access control method are of two different categories. One could be the wired medium, the other could be the wireless medium. For wired medium, you have the Ethernet, Ethernet and the protocol used is CSMA CD. Whereas if it is wireless medium, then the protocols used are CSMA CA and even IEEE 802.11 and Bluetooth is all part of wireless LAN. So as such, we have completed medium access control, CSMA CD as well as CSMA CA. And tomorrow, ma'am will be dealing with this Ethernet. Okay. It is as per IEEE standard 802.3. Ethernet will be the categories, the different types, the all that relating to Ethernet, that is wired LAN, will be discussed by ma'am in the next class. So while you are coming to class on Thursday, in the offline mode, probably we will be dealing with the wireless LAN. Okay, so mostly this week we will try to wind up this unit so that next week we will start with the network layer. So any doubt you have up to now, you can ask, and just stopping the screen share.